We are a consortium of Earth observation specialists working for the European Space Agency.
The framework in which we operate is twofold. The first guiding principle is the United Nations Sustainable Development Goal 11. Make cities and human settlements inclusive, safe, resilient and sustainable. The second framework is the Project Implementation Strategy in international financing institutions like the World Bank and other development banks.
Our aim is to extend and improve the use of satellite data for the monitoring of indicators in order to reach Sustainable Development Goal number 11. We also want to facilitate international development work in a globally consistent manner by using Earth observation data and methods.
We have covered 32 cities around the globe with a total of more than 510 products and 11,000 square kilometers mapped. Our basic products comprise status and evolution of urban extent, as well as land use and land cover and its change over time. More specifically, targeted maps include slum maps, maps of open and green spaces, building footprints and heights, infrastructure, as well as hazard and risk maps. Based on these maps, we generate spatial analytics and the before-mentioned indicators for SDG 11.
These tools are very much relevant because they provide evidence.
In general, the preparations of bank operations take several years, but in these cases, it only took around 6 to 8 months for the preparation. Thanks to the whole analytics, maps, and data evidences. The best part is that it was helpful to communicate with various stakeholders on the ground.
Today we'll have two speakers. First speaker is Jakub Balhar from GISAT, and the second one is Thomas Esch from DLR in Germany. Thomas will talk today about the background and give you an overview on the urban thematic exploitation, UTEP. And this will be followed by a practical live demo from UTEP with example from the word Sediment Footprint and Geospatial products, which will be given by Jakub. And then we'll have a question and answer session. Okay, so without further delay, I would hand over to Thomas Esch first for his first part and then to Jakub Balhar for their presentations.
My name is Thomas Esch and I kindly welcome you as well to this webinar. I am the leader of the team Smart Cities and Spatial Development at the German Aerospace Center, DLR in Oberpfaffenhofen in Germany. And in the context of our activities, we are actually developing the so-called World Settlement Footprint Suite. And also at the same time, we coordinate the implementation of the Urban Thematic Exploitation platform. So both, let's say, objectives of today's telecon. In this webinar today, as you have learned, I will be responsible for the first part, which aims at giving you a brief introduction to the Urban Thematic Exploitation platform on the one hand, and of course also about one of its key data sets, the World Settlement Footprint 2015. So the Urban Thematic Exploitation platform in general is an enabling instrument that represents a virtual environment which combines on the one hand open access to multi-source data repositories, also with dedicated data processing, analysis and visualization functionalities. On the other hand, it includes also mechanisms for the development and sharing of technology and knowledge in general. The UTEP project was funded, or is funded actually, by the European Space Agency, ESA, and it has started in the year 2014. Since then, the underlying consortium of 5 partners, which are namely the German Aerospace Center, DLR, and Brockman Consult, both partners from Germany. We have GISAT and IT for Innovation, both come from the Czech Republic, and the 5th partner is TerraDue from Italy. And since then, so 2014, we have constantly pushed the prototypic concept of the UTEP towards an operational platform. And from June this year, we expect to achieve a first, let's say, fully operational status with the UTEP. But now, before I go into the details of the platform, let me first provide you some details why we actually decided to develop a system such as the Urban Thematic Exploitation platform. Generally, we can see that the science and policy communities increasingly recognize that cities or urban agglomerations and the underlying urbanization process are at the center of global climate change and sustainability challenges. So basically, policymakers or decision makers need facts, empirical evidence, and theories on how to plan and manage cities and urbanization. And this, of course, is somehow reflected also in the various international agendas and concepts and initiatives, for instance, the Sustainable Development Goals, which you could find, because most of them or all of them actually somehow refer and relate to cities and urbanization in general. And of course, one key part, if we talk about this empirical evidence of facts, is big Earth data. And just to give you an example, if we talk about the European Sentinel satellite fleet as one of the, let's say, providers or collectors of big Earth data, we can here talk about more than 20 terabytes of data or images per day, which are collected. And of course, on the other hand, we all know that there is a rising amount of high performance computing and also artificial intelligence, which allow us to better and better analyze the content of these big Earth data collections. And this is exactly with the UTEP where we aim at. Because what we want to do is actually to create and share knowledge that helps non-expert communities in better exploiting the new opportunities that arise from this so-called big data era. And here with big data era or big Earth data, I do not only refer to Earth observation, but I also refer to all the kind of digital data collections which are available, let's say, on the urban or built environment in general. So this can also be statistics, or let's say volunteer geographical information which is collected, such as in OpenStreetMap, etc. So the key idea or intention of the Urban Thematic Exploitation platform is actually to collect all data and tools needed to access or generate actionable information in support of sustainable and livable cities at one place. So ideally, the remote sensing expert, the geodata expert, but also a kind of application user, be it an economist, should be able to work with a urban platform such as the UTEP. And the key components, as you can see here, are on the one hand, the processing power, which means high performance infrastructures to process and analyze data. Of course, as I said before, we have the big data collections, so big Earth data, that we want to put into the system. And of course, finally, the key is to transform this into actionable information for decision makers or scientists, etc. So the starting or entry point of the Urban Thematic Exploitation platform is the portal. It's a web portal, and I will show you later a bit more about it. Here's just the basic design. So on the top, you find the classical functionalities and functionalities of a website. You'll find more background information. And then let's say the key technical components are represented here in the lower part, which is on the one hand, certain data sets and products, which you can see on the geo browser. We also have a visualization and analytics center. Here, my colleague Jakub Balhar will give you a detailed introduction later on in the second part of the webinar. We have the Earth observation processing services. So these are on-demand services that you can use to process new data for new areas. And of course, another key component is the communication hub, which allows you to share information with other communities using the platform. Again, as I said, at the end of my part, my demonstration, I will also show you live what you can do with the different parts. So technically, as I said, we have a geo browser and a catalog in the background. We have kind of a WebGIS functionality with a visualization toolbox or center. We have a developer environment where you can actually even upload your own processing algorithms or programs or tools to analyze data. And we have this user forum. Also underlying the platform are 3 processing clusters with standardized interfaces, so OGC, WPS or WMS services. And one key, and this is also part of today's webinar, is of course the use of innovative products and services, which allow you to effectively derive information on the built environment and also combine different data sets in order to analyze the developments which are going on. And we've claimed this, one of the key data sets here in the Urban Thematic Exploitation platform is the word Sediment Footprint, or actually an entire suite, which is supposed to be also uploaded and released in the context of the Urban Thematic Exploitation platform. And the word Sediment Footprint actually is kind of a successor or follow-on activity to the Global Urban Footprint, which was also generated by the German Aerospace Center and was released in November 2016. Basically, the Global Urban Footprint represents a binary settlement mask that indicates the existence of, let's say, settlements all over the world in the 12-meter ground resolution. So this is full resolution, which is open and free for scientific use. And for any non-profit use, you also have an open and free version with a slightly reduced spatial resolution of 84 meters. This product is currently already used by more than 300 institutions from 43 countries. And now, as I said, the successor is the so-called World Settlement Footprint. Here we try to come up with a lot of improvements. On the one hand, we use completely open and free input data from multi-sensor. So this is, on the one hand, the Sentinel-1, so radar satellite data. And we also use Landsat data. So it's a US system which provides you with open free data. And as soon as we have enough data available, also Sentinel-2 multispectral information from the European Sentinel-2 satellite. At the same time, compared to the Global Urban Footprint, we use multi-date information, which means we take a collection of all scenes available for a certain time period. And we also work with multi-facility or infrastructure. So we have DLR processing infrastructures. We have the infrastructure from the Urban Thematic Exploitation platform, but we also integrate processing from the Google Earth engine, for instance. And compared to the original Global Urban Footprint, the World Settlement Footprint will include an entire product portfolio, starting with the WSF 2015, which is again a binary mask, a settlement mask, as in the case of the GUF. And on the other hand, it has a 10-meter resolution. And this basic product will then be supplemented or enhanced by additional information layers. On the one hand, the WSF density, which has a 30-meter resolution. And for all the areas indicated as buildup in the WSF 2015, this WSF density product will show you the percent imperviousness or impervious surface within 1 pixel. Next product is the WSF network, which allows you to describe the settlement pattern. We have the WSF evolution, again, the 30-meter resolution, and this will show you on a yearly basis the development of the build-up area from 1984 to 2015, so about 30 years of development. And then we have the WSF and also GUF versions of the 3D, which describes the average building volume. As you can see here by these indications, the WSF 2015 and the prototypic WSF density are already available at global level. For the 3 other products here, they are upcoming this or next year. So just to describe you and coming back to the WSF 2015, what the underlying data is, I just extracted this information here. On the one hand, we have the time scan Landsat data from 2015, which, as the name indicates, is based on Landsat. Actually, we collect for a certain time, here the year 2015, all available scenes. And in this subset here, you see an example from the city of Nairobi. And usually, as it is the case in multispectral data, we can find clouds, we have some haze, and we have cloud shadows. And with the time scan Landsat data, we actually aim at eliminating these effects by performing a temporal integration of all the different data sets which are available. Basically, from the original scenes, for the original scenes, we perform cloud identification, cloud masking, and also removal of shadow areas, etc. And then for each of the scenes, we derive certain indices. Here, as an example, you can see a visualization of the normalized difference buildup index, NDVI, on the red band, the normalized difference vegetation index in the green band, and the normalized difference water index in the blue band. We have even more indices in the background of this product, but again, as I said, in this visualization, you find the 3 indicators that I showed you. And of course, this again gives you an impression that wherever we are supposed to find buildup area, it should be in reddish colors. So the buildup index is high over a certain period of time, in this case, time period of 3 years, running from 2014 to 2015, 2016. This is again one baseline layer, so you can see for the World Settlement Footprint 2015, the timescale Landsat was generated on a global basis, which included the processing of more than 460,000 Landsat 8 scenes. From this, of course, includes 6 spectral indices, out of which 3 I showed you already. And for these spectral indices, we derive 5 temporal statistics. For instance, what's the mean vegetation index over the 3-year time period, what's the maximum NDVI, what's the minimum NDVI, etc. So in total, this included the processing of more than 1.5 petabytes of intermediate products and data layers. And the final product, which you can see here, even or still includes 25 terabyte of data. In addition, we supplement this information coming from the multispectral domain with SAR data, so radar imagery. And here, for this purpose, we used Sentinel-1, so a European satellite. Here we classified more than 250,000 scenes, also collected for 2014 to 2015, in 2 polarizations. And again, we derived the 5 temporal statistics, so the minimum backscatter, the maximum backscatter, mean backscatter, etc. And this product has a 10-meter spatial resolution. And then we merge these 2 in a final rule set to really identify build-up areas. And how this looks like, I want to show you in this example here. So this is a optical representation of the area of Lagos in Nigeria. And then, of course, for this, we first generate, as I said, the timescale Landsat data set. Again, in this classical visualization that I explained before, all build-up areas or areas showing permanently non-vegetated areas should appear in red. And here we have the complementary information from the timescale Sentinel-1. Here all areas appear in these bright spots. So in radar data, all potential build-up areas should appear in a brighter color. So this bright spots should be indicated or related to build-up areas. And if you combine the information from the Landsat timescan and the Sentinel-1 timescan, we get this build-up mask of the WSF 2015. So all areas shown in black here are somehow related to the build-up regions. And of course, we have this, as I said, available at the global scale. And you can find this information already at the UTEP portal. So I will now jump to this portal. Again, here so if you click this URL that I identified at the beginning, you come to the key or central website as an entry point. And as I showed in my presentation earlier, you find the classical background information on the top. So for instance, if you're interested in learning more about how to use the UTEP, you can click on demos and tutorials, and there you will, for instance, find a collection of demo videos and also tutorials how to use our system and what to do with it. If you have key questions, for instance, you might find answers to it in the quick start. And as I said, let's say the key functionalities, also from the technical point of view, and key functionalities that you can actually use are provided here. And again, my colleague Jakub will show you or give you a dedicated introduction to the Visualization and Analytics Center. And of course, you will find all the information which is available at UTEP in our data and product showroom. So for instance, if you go there, you will also find here, let's say in the first row, the WSF 2015 data in a geo browser. So you can scroll in a certain region and take a look at the data. Soon you will also be able to download the information layers. So I also mentioned the experimental WSF density. At the moment we have a prototype here which was still based on the GUF data. So it's the imperviousness for the build-up area, which you can then describe and analyze with this product. So you see where it's red, it means it's more or less 100% build-up area. So either a building or a street or a paved place. And if it's, say, zero imperviousness, it's kind of the inverse. Let's say it's the greenness or in this case, completely green areas of vegetation covered area. Again, this information is available at global scale, and I think this is, of course, also a very useful product. Also, I mentioned already in the context of the WSF, the timescan data sets. can also find them here and take a look at them in the Geo browser. Also for different years, so you can also activate the visualization for 2010 global data set or 2000. Also, in this case, different combinations of the layers underneath. Another data set that we use is the geotech tweets. So here you can find information about the number, the sum of tweets released within a certain or 1 year time period in 2015 actually. So all this you can find in the, let's say, data place where you, the data and product showroom, sorry, which allows you to browse all the data which is available. As I said, another key functionality is also that you can create data on demand or even develop your own processor, let's say, which allows you to generate new data sets and also let other users, if you want, generate data with your processing functionality. So if I click on this, for example, we'll see that here on the right-hand side, you find different processing services which are available. At the moment, they are loading. So briefly, there should, for instance, appear processors which allow you to generate time-scan products that are showed on demand, for instance, based on Sentinel-2 or also based on Landsat. And this portfolio will be updated soon, so there should be even be available more on-demand services soon. For instance, if you would click on this processor, it allows you to, for instance, define a certain area of interest here. Say you can upload your own, say, shapefile to define area of interest, or you can just, click on it and define it, and then also integrate it here later on, let's say with the polygon that you just defined, and then define the date for which you want to, starting date and ending date for which you want to process time scan data set. You can also set other parameters and then just on demand, let's say, calculate the costs. And this is fine. You can start the processing. And once the data is processed, you will be provided with the URL where you can download and access the data or further analyze it. And then, as a last example, before my colleague Jakub will take over, I can show you what the communication hub means. So this allows you to organize you in form of a community and also share information with other communities. So here, just as a demo, we have the starter users. For instance, you can enter such a community and ask for access. So here I'm already logged in as Thomas Esch, so I'm known to this community. That's why I can directly see, for instance, who are the members. And I get an overview of the members again, of the usage. So we have 15 active users. You can see how many jobs were submitted, how many jobs succeeded, etc. And if I want, I can even easily share these jobs and the data sets behind it with my community members, but also other users. Here we see an application. So in this case, we just have one active application which was developed and used by this community. And then we can share also other activities, for instance, publications, etc., which are not available yet here. But for instance, if I go back, for instance, to the Puma community, then one might even see there are more services available, more activities, and also here, WS service, etc. We can find examples on how this community uses information and what they can share. Okay, with that, let's say I'm finished with my part, and I can now hand over to my colleague Jakub Balhar.
The Visualization Analytics Center Thomas talked about before is accessible via the Visualization and Analytics Center on the main UrbanTep page. When you click, you are welcomed with the information about UrbanTep and the applications on the left side that explains different data sets and that are available and allows you to explore them. In this seminar, we will be focusing on analysis of world settlement footprint. The World Settlement Footprint is a new product derived from the Earth observation data by DLR. We will take a look at the statistics that were in general produced by UTEP during its duration, and we will take a look at the urban statistics for Earth observation for SD. If you are interested to know more, you can just click through the applications and see what's available there. So first, we will start with the World Settlements Footprints analysis. Here, you can see on the top the description and the information about the application. In this case, it mainly talks about the World Settlements Footprint. Then you can see some already prepared visualizations, information that you can start from. Explore Yourself is the basic point where you can see nothing, no charts, only map, and all the tools that you can use. I've already prepared an example with the Mexico, so I will already go to the Mexico urbanization and population. Clicking on this view will bring us to the analytics tool itself. The tool consists of multiple parts. On the top, we can see the link leading into the urban tab and analysis as such. Below, we can see the different places that may be relevant for us, themes, if applicable, it's applicable in EO4SD, and periods, if applicable again. When we arrive, we see in the middle a map with the products and administrative units that are relevant for the given application. To select the layers that we are interested in, we have a tool on the left. In the layers, we have a different background layers that we can use to visualize the information above. Quite relevant in many cases would be Bing Aerial or Sentinel-2 Cloudless Layer 2017. Custom WMS layer represents WMS layer that were added to the scope that are available to visualize. In this case, it's WSF, because it's only for 2015, and it's already shown on the map, as you can see. The map is actually a globe. So via the tools on the right or via your mouse, you can get to a point where you will see also the elevation. This example is kind of related to the Sustainable Development Goal 11.3.1. So for the WSF 2015, we prepared statistical information based on the global administrative units for the WSF. So we have the urban area. Here in the chart to the right, we can see the percentage of urbanized area in the Mexico in this case. It's on subnational level. And we can see the total population in these areas, which is based on the GPW population. The right area serves for the charts. In this case, of course, we can just find the areas that are most populated or most urbanized. But what is usually interested is to understand the correlations. So that's why I have prepared a scatter chart. If there was no chart and you wanted to look at the correlation between density of the urban and density of the population, it's possible to do it by clicking on plus, selecting the scatter chart, and then selecting the available attributes. Here you can see multiple attributes that you can work on. In this case, it's relevant urban area and GPW population. By default, these areas, these attributes are just the attributes. So it's in the square meters and in inhabitants. This won't tell us much, actually. It will tell us that the bigger areas has more population. That's not really that interesting. So what we can do is we can say that we are interested in the percentage of the area that's urban. That's done by the normalization types. There are multiple, but the one in this case is area. And we can do the same normalization for the population. In the case of population, it's not going to be percentage, but inhabitants per square meter. It's possible to change the area units and to select inhabitants per square kilometer. Per square meter, it wouldn't be really interesting. It would be always around 0. So at the moment, we have the attributes selected for the scatter chart. So if we click on OK, we will see the new scatter chart that we just created. The charts are also interactive, so if you want to, you can of course zoom. You can select the areas that you are interested in. Reset zoom. If you want these two outliers in Mexico to see why they are not really in the bulk in the top, in the bottom left, you will see that they will be shown on the map. On the left, there are possibilities to visualize the selected area, either filled as you can see now, or just as outlines depending on what you want to show. To put the information into perspective, it's also possible to provide a thematic layer. What you see here in the black and white scale is actually the urban area. It has the following legend. These choroplets are generated dynamically, so not on top of the ones that I've already prepared, which is the one with the population and urban area. You can see the legend for it. You can, of course, overlay the layers and select the opacity for the layers. So if it's relevant for you, you can get this overview as well. But on top of that, it's possible to go to the configuration of layers. And here you can create your own or change the characteristics of the choroplets that are provided here. Choroplet params allow you to decide how will be the values distributed, continuous, equal, or quantiles, and how many categories will be there. Otherwise, the configuration of the choroplets is very similar to the configuration of the charts on the right. So again, you select one or more of the attributes you're interested in, and then in setting, you can either modify displayed units or you can normalize the information. So this is the core that will allow you to explore WSF with GPW for one of the countries that I already prepared. If you're interested in another country, there is the areas filter on the left. Areas filter on the left give you access to a whole tree of the gardens that are available in the tour. Here we can see that we are in Mexico. Clicking on the plus opens and shows other areas. For example, if I went for Thailand, you will see that in the charts now I see the Mexico as well as the Thailand because both of them are selected. If you see something that you like in the charts or in the maps, it's of course possible to generate snapshots. Snapshots for the charts are generated by clicking on the snapshot on the chart. The prepared snapshots are stored in the snapshots tool on the top side. Here, it's also possible to create a map snapshot. It's possible to download the snapshots. It's very simple, of course. For the charts, if you want to work with it further, it's possible to export them to the CSV, as you can see. And if you want to export the data, the statistical data, you can do so using areas filter. Here you can select based on the attributes that you care for. And then you can export the selection to the GeoJSON, XLS, CSV, or shape, so you can work with the statistical information further. On top of that, there are a few map tools that might be relevant for you. If you are already somewhere, just want to get some information about some of the areas, it's possible to have the map tools here. Either you can select the area, of course you can clear the selection to simplify things for you, or you can just use the info tool. When you select this info tool, it's red, and it means that when you click on some of the areas, it will get you the information about the area, as you can see here. In case there are some other layers than just the default ones, it's also possible to get the information about layers via the information tool, but this I will show later in the EO4SD scope. So this is all for the Sediment Footprint. There's no more to say. Well, there is one thing, more thing, that's sharing. But for sharing, you need to be logged in, so I will again show it later. All of the functionalities that I'm showing to you now are available to everyone. So you don't have to be logged into Portal, you can be here as a guest. In a few minutes, I will show you addition that's done by the logging in. Next application that I would like to show is the UTEP product statistics. Here we will go with the Explore Yourself, because here you will be usually looking to explore and see what was produced in the context of the UTEP. At the moment, you should already know mostly about how the UI looks, so I won't explain the UI itself. I will just go through the layers that are available. So on the left, you can see that you have, again, the urban layer. For 2015, it's WSF. For 2012, it's the information coming from Global Urban Footprint, which is a predecessor. Then there is the timestamp layer that was produced. It was produced for years 2000, 2005, 2010, and 2015. Here we have two WMS expositions showing different bands and different combinations. Then we have the information about tweets, the amount of tweets that was tweeted in the year 2016, amount of night lights in the year 2015, and the gridded population of the world for 2015. They will load for a bit, they're not in cache at the moment. Not all of the information and layers are available only for year 2015, but as I already told for TimeScan, they are also available for 2010, 2005, and 2000. I will wait a bit for the night lights and grid population world to be displayed. So now you can see the grid population world and the night lights that were generated and shown. If you want to see, for example, the change in the population throughout the years, then the simplest thing is to select another period. As you select more periods, you get more maps that each map shows the data relevant for a specific year. In the case of GPW, it's available for all 4 years, so you can see and compare the information throughout the years. Now we have all the maps. So if you, for example, go to Africa, when we zoom in, we will see some of the changes in the areas. Mainly, for example, here you can see that the amount of population 2000-2015 is, the amount of population is growing. It's actually very visible. As you can see, there were some other layers loaded on the left, urban imperviousness and others. These are the layers that are not mapped for all the years, but only for some, so you won't be able to show them in all the years. When we have the grid population world, it's one of the maps that have some information associated with it. It's not just urban mask, and as such, it's possible to explore it via the map information tool. Clicking on the layers, you will get the detailed information about the layer and the properties, in this case, the amount of the density of the population for the specific pixel. You can do the same for other layers that are available here, not for TimeScan, but for other layers. I believe for WordPop is also available. Okay, meanwhile, if you want to explore what's there for the attributes that are linked, you can see that there are 3 different types of statistics. Some are TEP produced. These are urban areas, population, tweets, the average height of the affected area. These are the attributes information that we generated statistics for from some of the layers that were produced in scope of the UTEP or are auxiliary and relevant layers. Then we also integrated on the country level the statistical some information for World Bank Group and from United Nations. So if I go for the table, I can select 2 of them. And here you will see the percentage of urban population in different countries throughout years and health expenditure. You can play with this and look through different charts that are available and figure out the correlations that you didn't expect before. So this is for the UTEP produced statistics. And before I will go for the O4SD, I will log myself in so that I can show you how to share the results that you find out interesting. So sign in is either here on the main page, or it was here. I'm logged in already, so I will come to Research Analytics Center. I will have more scopes available. I will come anyway for the O4SD Urban. And here I will be showing some of the examples of the analysis of land use land cover in the scope of Earth observation for sustainable development. In the case of this scope, we were focusing on the analysis of Dhaka area and understanding how is the land formed and what changed between the years. The input layers are land use land cover layers that we can see on the left. We can get also the metadata information that shows the information about who produced the data and what's in there. We can select from more background layers than in the previous case. This is site specific. And on the right, we have prepared charts. So in this case, it's already prepared. There is lots of visualizations that were prepared by the people from the O4SD. You can see the visualizations that are available. Visualization means the combination of the map and charts and layers that are displayed in there. This allows you to really go through the details, also choroplasts as well. There are different teams that focus on different areas, for example, open and green areas here. For each team, there are different visualizations that you can go through. So let's say that now at the moment, I'm focusing on some of the areas inside of Dhaka. I want to share the focus on this area. Let's say I will select a few of them that I consider interesting. It's better visible this way. Okay, so I want to focus on this area. It's visible in the charts, and I want to share this information with some of my colleagues. Then there is the share view on the top right. This allows us to create a new view that you have seen here. And this view and the information will be shared with either specific user or specific group. In the case of the groups, you will see only the ones that you can share to. And you might be able to share also to guest and user. User means anybody who is logged in. Guest means anyone, regardless of whether they are logged in. So let's say in this case, I will share it with every user. I provide the name for the data view. So green areas in the center of Dhaka. It's possible to provide some description, selection of interesting area to cover in next article, for example. This is something that will be shown, and the language in which the UI will be shown. At the moment, Czech and English are supported. We expect German and probably other languages to be added soon. So I will select English in this case, and I will share it. Sharing will create a new URL that you can share with your colleague already, or it will be also shown in the views to you and all the people that have access here. If you ever forget what's where in the application, there is an app tour, or for the new ones, it goes through different things that are part of the application. Okay, so that's all from us, and now it's up to you. You can go and start exploring the data that are there and figure out interesting correlation and interesting things that you can use in your own work. Thank you.